Happy morning to one and all present here. In the last unit, we discussed about the content on thin cylinder as well as the thick cylinders. So today, our friends, we will discussing under the case study about failures in thin cylinders. So let me see how our friends will be explained by the thin cylinder concept. So let me see one by one. Thank you.
Myself, Mohammed Shami, I would like to share about failures in thin cylinder. Thin cylinders are widely used in engineering applications such as boiler, pressure vessels, pipelines, and storage tanks, etc. A cylinder is considered as thin when its wall thickness is small compared to its diameter, which simplifies stress analysis. When these cylinders are subjected to internal pressure, two main stresses are developed: hope stress and longitudinal stress. Among these stress, hope stress is more critical and usually responsible for failure. Failures in cylinders are occurred due to excessive pressure, corrosion, material defect, or fatigue over time. Uh, um, Understanding these failures is essential to ensure safety prevention extent. Time.
Let us consider a real-time case of a steam boiler used for a small manufacturing plant. And the boiler had been operated by many years and was used continuously under high pressure and temperature conditions, since it has played by a circular role in the producing the process. It was rarely shut down, which gradually increased stress on system over time. One day during normal operation, boiler suddenly blast under cautious and powerful explosion. It unexpectedly failure result in server damage to near machines and information more important, highly damaged situation. It create high damage and present of all highlighting serious and safety risk associated with pressure results. What made this incident more critical was the various visible warning signs the outside. The boiler appears from normal expecting, making it difficult for operation to detect any issues and advantages. However, increasing the material made by a weakness and time due to continuous high pressure, repeatedly high and cooling process. Thank you.
I would like to continue with the further topic. The primary reason for the failure of the thin cylinder was the development of the excessive hoop stress inside the vessel. In thin cylinder pressure vessels, hoop the stress acting circumferentially around the cylinder. It is the most type of stress. Under normal stress, the thin cylinder increases, and the stress developed in the wall of the vessel also increase proportionally. Under normal conditions, the material is designed to withstand these stress with safe limits. However, in this case, the situation became more severe due to the gradual reduction in wall thickness caused by the corrosion over time. Corrosion is slow by dangerous process that weakens the material by reducing its effective thickness according to the stress relation for thin cylinders. Decrease in thickness leads to significant increase in stress as the wall became thinner. It was no longer capable of handling the internal pressure safely. As a result, the hoop stress increased beyond the permissible stress limit of the material. Once this limit is exceeded, the material begins to fail. It is important to note that in thin cylinders, the hoop stress is approximately twice the longitudinal stress. Because of this, hoop stress becomes the dominant stress responsible for failure. Due to the dominance of hoop stress, the failure occurred in this form of longitudinal crack. Means the cylinder split along its length, which is a typical failure pattern. The further topic will be continued by my colleagues. Kenny.
I'm going to talk about stress analysis. The failure mainly occurred due to the exclusive hoop stress developed in the cylindrical vessels. When the internal pressure is inside the cylindrical cylinder increases, it includes the stress in the wall of the cylinder. Among these hoop stress, circumferential stress is the most critical because it acts as a tangentially around the circumference and tends to the split of the cylinder open along the length of the cylinder vessel. Hoop stress is given by delta H sigma H is equal to PD divided by 2T. From this relationship, it is a clearly loop stress is directly proportional to the internal pressure and diameter and inversely proportional to the wall thickness. This means that as per the pressure of increases, stress increases. As the wall increases, wall decreases, hoop stress increases differently. Thank you.
And we have to conclude about the failures in cylindrical vessels can be very dangerous but are mostly preventable with proper care. This case highlights the importance of irregular inspections, maintenance, and monitoring of pressure levels. Using corrosion-resistant materials and protective coatings can help reduce thickness loss over time. Safety valves should always be installed to prevent excess pressure buildup. Engineers must also ensure that vessels are operated within their design limits. By following these safety measures, industries can be avoid accidents, protect equipment, and ensure the safety of workers. Understanding that these failures help in designing stronger and more reliable pressure vessels for the future use. Thank you.
Our friends are explaining the concept about the case study in failures in thin cylinders. So may all know the failures, what was the occur due to the some of the reasons tell by one by one. So if there any clarification for this case study?
No, sir.
Okay guys, thank you all.